really talked a lot about this up till now, but it's an important step that we now consider. What are the domain and the range of each of these functions? What are the domain and the range of each of these functions? Let's consider sine theta. So y equals sine theta, for example. And usually we talk about domain as being all the x values, but in this case it means all the theta values. What are all the different things that theta can be. So the domain of this, is there anything that theta cannot be? Let's consider that unit circle first of all. We talk about the fact that you can just keep going round and round and round and round that unit circle. So theta can be anything. Okay, so the domain of these things going from, and again we saw that when I showed up the wave function the other day. It just keeps going on across the page, doesn't it? If it keeps zooming out, you just keep seeing more of it. So there's an infinite function, just like lots of our functions we've had, the domain is infinite. For a quadratic function, the domain is infinite. X can be anything. Y equals x squared. Is there anything that x can't be? No. X can be anything. It's an infinite domain. Okay? So I mean, what about the range though? What about the range of this function? So when we take sine of an angle, is there a certain range that that answer can be within? And the answer is yes, but what is that range? Okay? So to consider that, let's look at this. What does sine mean? Sine means opposite over hypotenuse. So sine of theta, opposite over hypotenuse. Can the opposite side ever be bigger than the hypotenuse?
No.
No. So in this fraction, can the numerator ever be bigger than the denominator? No. So what does that mean for the range?
Less than 1.
Sorry?
Less than 1.
Less than 1. Absolutely. Now, let's put 1 out here for the moment. Can it be 1? Now, in a triangle it can't, but we did see in the unit circle, remember saying the unit circle that sine is like a y value, and that's 1 and that's negative 1, and so the sine can get to 1, but it can't go above 1. Okay? And so 1 is included in the range. What about the other end? What is the lowest that sine can ever be?
0.
Well, it can be 0 here. What about down here?
Minus 1.
Minus 1. Okay? And if you try sine of 270 degrees or sine of 3 pi over 2 radians, you'll see that the answer is negative 1. Okay? And so, we can actually have any number between negative 1 and 1, including negative 1 and 1. It can be 0, it can be 0.00001, it can be 0.999, it can be 1. The range of a sine function is negative 1 to 1, inclusive. And we'll see that the cosine is exactly the same. Domain is infinite, range again, negative 1 to 1, including that. What about tan? Let's consider tan. So if we consider, and we talked about this the other day, that tan theta is the same as sine theta over cos theta. When cos is really close to 0, what happens to that tan?
It increases.
Yeah, and it actually increases to infinity. So if you had something divided by 0.000001, the answer is massive. Okay, and so we know that in a fraction, when the denominator of a fraction gets closer and closer to 0, the whole value of the fraction increases to infinity. And so, that's obviously the domain in a minute, that's the range. So at one end, it actually goes to infinity. What about the other end? And it's maybe a bit hard to see, but it actually goes to infinity the other end too. So the range of tan goes from negative infinity to positive infinity. Because it could be, if you had a very tiny number here, like positive infinity, and if that's positive on top, that's positive down there. But when that's positive on top and that's negative down there, the answer is a very huge negative number. Because positive divided by negative. Okay? What about the domain though? Is there any value of theta that cannot exist?
No.
Well, there is, because what can't you have on the bottom line of a fraction?
A zero.
A zero. Is there any value of theta that makes cos zero? Let's go back to here. Remember, what is an x or y that is represented by the cos here? Do you remember? It's x. Okay. Is there anywhere on this unit circle where x equals 0? Those two spots there. Okay. So those two spots there, tan does not exist. Because the cosine of those of angles is either pi over 2 or 3 pi over 2. So cos of pi over 2 equals 0. And you cannot have a 0 down there, so it cannot be pi over 2. Also cos of 3 pi over 2 equals 0, and so it can't be in there. Now it's a bit hard to write this one in interval notation. So let's just write like this. And in fact even the negative one too. So that's kind of a pattern for things with tan can't be. Sorry, did I say can't be? Equals, I mean can't be. And so it's kind of, let's just, as we think about it, without worrying about writing it so much. For the moment, let's just think about it like that. Theta cannot be those things. That one's a little bit more conceptually difficult, but these two in particular, we need to recognise. Sine theta and cos theta can never go beyond negative 1 and 1. Okay, they're the highest and lowest numbers it can be. And because of that, cosec and sec therefore are all greater than 1. Because when you flip those numbers, all of a sudden a number that is less than 1 becomes greater than 1. Okay, the reciprocal of a half is 2. The reciprocal of 1/10 is 10. The reciprocal of 1 over 100 is 100. So any number that is less than 1, when you have the reciprocal of it, the answer is greater than 1. And again, that's just some stuff, just to kind of get you thinking about what those reciprocals actually mean.